My name is Ben, and my project is the assessment of saccadic eye movements post-stroke. In a 2019 study by Herder and associates, it was found that, for healthy controls, being able to see their arms makes it easier for them to make controlled movements. Now, this isn't really surprising to most of us, as we all kind of had experience with this. Think reaching for a light switch in the dark versus when the light is on. However, the surprising part of this study was that for some survivors of stroke, being able to see their arms had no effect, and sometimes even an opposing effect, on the subject's ability to locate their arm and make a controlled movement. Stroke, being the second leading cause of disability worldwide, negatively affects many people's daily lives. Sensory issues only makes things harder and can be detrimental to recovery. Saccades, or the rapid movement of the eye towards a target, is a key eye movement associated with information processing and attention. It's the movement you'd make when looking between your hand and the coffee that you're reaching for. So, my project aims to characterize saccades to visual targets in a group of stroke survivors and a group of controls. It's a part of a larger series of studies aimed to investigate the integration of participant vision and participant proprioception, or basically the awareness of one's body position and movement. In the future, discoveries made about eye movements will be analyzed in conjunction to data on the proprioceptive abilities of the same subjects in order to paint a clear picture of what's kind of going on. When analyzing saccades, the metrics that I looked at were latency, spatial error, number of saccades made to reach a target, and peak and mean velocities. Latency is the time between a stimulus appearing and when a participant starts a saccade. Generally, the shorter this is, the quicker an individual can take in new developments in their surroundings. Spatial error refers to how far the endpoint of a primary saccade is from the target that is on screen, while the number of saccades is the amount of saccades a subject makes before their eyes get to the target or a point closest to it. For example, a saccade may fall short of a target, requiring corrective movements to close the gap. These two metrics play a large role in assessing how effective a saccade is when it comes to actually focusing the eye onto the target of interest. Finally, the average velocity refers to, the average velocity of an eye during a saccade, while the peak velocity refers to the fastest an eye moves during a saccade. These values are associated with the cost of a saccade, since when you actually make that movement, you temporarily are unable to take in new visual information until the movement is completed. We hypothesized that in a visual saccade task, control subjects will have more accurate saccadic endpoints, shorter latencies, and faster saccadic velocities than stroke participants. To collect data, we used the Kinarm robotic exoskeleton with an integrated eye tracker to follow and record where the participants look as they perform tasks within the virtual reality of the robot. In the task that I analyzed, green targets randomly alternated 10 degrees to the left or 10 degrees to the right of a central fixation target for a total of 60 times. The data then underwent filtering that cut down on things like noise and predictive saccades. We found that stroke participants showed significantly slower saccadic velocities, required more saccades to reach a target, and showed greater spatial error compared to control participants. When it came to latency, there was no significant difference between control and stroke groups. These results potentially indicate poorer visual information processing and slowed visual search in the stroke group. The general decrease in saccadic efficiency and effectiveness may also partially explain the challenges some stroke survivors have when it comes to integrating proprioceptive and visual inputs. Ultimately, the findings of this project can hopefully be a stepping stone in the development of more effective rehabilitation techniques that incorporate both sensory and muscle-based work, techniques that currently aren't as widespread. Thank you.